So now that we've talked about how to solve systems, we're going to talk about a couple of scenarios that are kind of special and unique that may show up and how to identify them. So first off, when we have been working with, if the solution sets that we've been finding, we have been able to find a solution, that is going to be graphically this first one where we have intersecting lines, okay? Now, with intersecting lines, we're going to have exactly one solution. It is going to be what's called consistent. Consistent just means that I'm able to get an answer. And then independent means that I have the two separated lines that I can see. Now, another scenario that could come up is the fact that the two lines or the two equations could in fact represent, in a graphing standpoint, the same line. Now, if that's the case, then any ordered pair that was worked on one line then would automatically work on the second line. So there is an infinite number of solutions. Now, since I do still get solutions, that is consistent, okay? We just have lots of them. Now, because I can't see the two separated lines, these are what are called dependent, okay? Now, the third option is actually that the two equations represent lines that would run parallel to each other. And since we know that parallel lines never cross each other, we know that there's never going to be a solution. So there would be no solution to this. It would be inconsistent because there are no answers, so there's no solution to this. But this would also be considered independent because we do still have those two separate lines. Now, we're going to take a look visually, graphically. We can see the options of how this would happen. We're going to take a look at how this would look if we were doing it through one of the other methods, okay? So the first one scenario that we're going to look at is we've got 5x minus 2y equals 4. And then I have negative 10x plus 4y equals 7. So we're going to take a look at this one, okay? Now, this one is set up really nicely for elimination, okay? I've already got all my variables on one side. I am already seeing kind of some opposite sign things running around, so it looks wonderful. Now, what I'm going to do, 5 and 10 will match up at 10. 2 and 4 will match up at 4. So I'm going to make my y's match for this one, okay? So again, I've already got positive and negative, so I just need to get a quantity here. So 2 times 2 will give me 4. So now if I distribute through, I get 10x minus 4y equals 8. And then I have negative 10x plus 4y equals 7. Now remember, we were trying to make our y's match up, and they do in fact match up and will cancel off. But notice here I've got 10x with a negative 10x. Those also cancel off. So I am left with nothing on this side, and I do have to represent that with a 0. And then 8 plus 7 is 15. So the question is, does 0 equal 15? And since we'd say no, then this is our no solution. If we were to have graphed these two equations, they would have been running parallel to each other. Okay? So let's take a look at another example. Okay? And so for my other example, I'm going to use x equals 4y minus 8 and 5x minus 20y equals negative 40. Okay? Now, this one is already set up really nicely for substitution because I already have that x equals thing up here in the top end. So I'm going to underline that in blue. And so I'm going to replace this x in this equation with what that is. So I've got 5, 4y minus 8, and then minus 20y equals negative 40. Okay, so distributing, I'm going to get 20y minus 40 minus 20y equals negative 40. Now, if I go to combine my y's, 20y minus 20y cancels. And that leaves me negative 40 equals negative 40. Now, even if you were to try and move the 40 at the same time, you're still going to end up with 0 equals 0. So in this scenario, because this is a true statement, this would be infinitely many. Okay, it is not all real numbers, okay, because all real numbers implies that I can pick anything I want. It is infinitely many. I still have to pick ordered pairs that work within the equation. So for example, if 0, 0 doesn't work, 0, 0 isn't a solution. So I still have to find ordered pairs that work inside of this, but there are going to be infinite number of solutions. Now, the thing to note is that in both of these scenarios, all of the variables canceled off. Okay, so all of the x's and all the y's canceled away and went away. That is the indication that says you're in one of the specialty cases. That says you're going to be either a no solution or an infinitely many. So that's kind of the telltale sign, and then you just make a decision based on whether or not the resulting information that you have is true and it's infinitely many, or false and it's no solution.